Welcome to a new module of this course on data warehousing, and this module is on extract, transformation, and load. That is ETL in short. So ETL is actually the backbone of a data warehouse, and it is responsible for bringing the data from the source systems, which are typically distributed, into a central repository, right, which we call as the data warehouse. And it is so important that any data warehouse team ends up spending like almost 70% of the time of the project time on ETL. So it is a very, very important subsystem of a data warehousing system, or important component of a data warehousing system. And unless it is working fine, the data warehouse cannot function properly. So I have tried to divide this module into three video lectures broadly. And the first lecture will give you an overview of the ETL system, and it is a kind of an introduction to ETL. Then we'll follow it up with another lecture on the subsystems of ETL, and there are around 34 subsystems, so I'll see if I can cover that in one video lecture or in one session, or maybe I'll split it into two sessions. Because one session was going to get very long if I plan to discuss all 34 subsystems. And then the final lecture on this would be on the ETL steps, and that would kind of tell you that what steps are involved. So there are different aspects of ETL, and we'll touch upon each and every aspect of ETL in this module. Right. So let me begin. So just a piece of information. So the material for this, most of the material for this has been taken from the Kimball's book on the ETL toolkit, and although the same material is available in the data warehouse toolkit book that we are using as a textbook, plus the data warehouse lifecycle toolkit. So there also it is covered, right? But the more detailed discussion is given in this book. So introduction. So as I told you, there are three steps in this: extract, transform, and load. So extraction basically means, or here we try to answer this question, what data we want in the data warehouse, right? Transform, it is about in what form you want the extracted data in the data warehouse. So once you have extracted some data, or once you have decided that this data has to be there in the data warehouse, so in what form? Okay, it should be there in the data warehouse, right? So it touches upon a lot of aspects of data transformation. So we will talk a lot about data transformation and what kind of transformations the data should go through before it enters the data warehouse. And then the third step is load. So some authors also call it transfer, right? So some call it the ETT. In some literature you will find the word ETT, that is extract, transform, and transfer. But typically we use the word load. So load the transformed, extracted data onto the warehouse. So this is a broad explanation of the terms ETL individually. Some more details: extract relevant data from the source systems, transform data to DW format. So here we are going to typically use the dimensional framework, and then build keys, etc. So keys, as you know, we had introduced what are called as surrogate keys, and I'll be talking about them in a lot of detail in the coming lectures. So the dimensional modeling, like while introducing the dimensional modeling framework, And during the grocery store key study, I introduced this term surrogate keys. So surrogate keys are also generated during the ETL phase. And then we also cleanse the data that we have. So data cleansing is a very, very important task. And once we have done this, so we load the data into data warehouse, and while we load the data, we build aggregates. Like aggregates are summary records where you try to pre-compute certain commonly used or queries which require aggregates, so those get benefited by building aggregates. So we do that in this step. So some more things about ETL. So backroom or green room of the data warehouse. So Kimball uses the word backroom. Green room is like, as you know, it's behind the stage kind of activity. It refers to behind the stage activities, and this is where the actors and everybody gets ready to appear on stage. So like the green room for data warehouse means that this is where the data is actually prepared to be before it is presented to the end user. And we, while discussing the components of the data warehouse, we discussed about the data staging area. And the staging area actually is being, the word staging has a different meaning in data warehousing. And also the way it is used when we talk about data staging area has changed or has evolved over time. So people now no longer use the word data staging area, but they use the word backroom, right, for this, right? So we'll also be using backroom in place of staging, data staging area. Staging basically in data warehousing means when you try to write data onto the disk. So that's what we call a staging. And analogy is with the kitchen of a restaurant. So a restaurant's kitchen is designed for efficiency, quality, and integrity. And throughput is critical when the restaurant is packed, when there are lots of customers. So throughput, so you should be able to prepare the meals in quick time, right? And meals coming out should be consistent and hygienic. And for this, we need what are called as skilled chefs, right? And patrons or the customers are not allowed inside. And because of various reasons. First is that it's a dangerous place to be in. There are sharp knives, there are hot plates there. And of course, you don't want to share your trade secrets with them, right? So ETL design and development, and it's, as I said, most challenging problem faced by the data warehouse project team. And 70% of the risk and effort in a data warehousing project comes from ETL, and has 34 subsystems. And it is not a one-time effort. Say when you have just built your data warehouse, at that time you want to bring in all the data, historical data, into the data warehouse. So that is we call as the initial historic load or initial load. And then every period of time we need to refresh the data warehouse to bring in new data as it is generated in the production systems. And automation of ETL process is very critical, because unless you automate this, right, it'll be very difficult for you to be running this every period of time. So automation is critical, and we don't want, or we want to, in other words, we want to minimize the human intervention that is required in the ETL process. And then the backroom architecture. So this is, as I told you, ETL processing happens here, and availability of write data from point A to point B with the appropriate transformations applied at appropriate time. So this is what is important. So availability is to make sure that data moves from point A to point B at the right time, and the right kind of transformations are applied. I'll be talking about transformations in a while, and give you details about what kind of transformations are actually carried out. And then we have ETL tools which are largely automated, but still they are very, very complex systems to work with. So before I move on to the ETL steps, we need to do a quick requirements. Quick requirements basically mean that what are the requirements of an ETL system. So first requirement is that of productivity support. So it should provide a basic development environment capabilities like code library management, version control, and check-in, check-out of the data, right? And similar other activities that are required for building any kind of application, ETL application, right? Then usability, that is the second aspect. So must be as usable as possible, and users prefer a GUI based, that is graphical user interface based tool. And system documentation is critical, and developers should easily capture information about processes they are creating. So it has something to do with the metadata. So this metadata should be available to all. So that is what is a requirement. And any kind of data compliance issues should be addressed by the ETL, and it should be metadata driven. Services that support ETL process must be metadata driven. So when we talk about metadata, again that is, I think, module number 8. So again we'll be revisiting all these points. So I'll not provide too much details at this point of time about metadata, but it is something that is very critical, and everything that you do in the ETL must be captured in the metadata. So continuing with the requirements, we then have what are called as the business needs. So it is basically the user's information requirement, what kind of information that they are looking for. And compliance, this came in the previous slide, but here I've provided some more details. Must provide proof that the data reported is not manipulated in any way, right? So as you've seen that, especially in databases, data can be manipulated very easily, right? Unless you have all the checks and balances in place. So compliance agencies may ask you that how can you make sure that the data that is reported is not manipulated in any way. So you have to be prepared for that. And data quality is of utmost importance. So here also these are like slightly conflicting kind of requirements. So one is about data quality. So here we want to make sure that the data that enters the data warehouse is quality data, that is, it is error free and it does not have any kind of problems. But at the same time, data warehouse should also reflect upon the data that is captured by the production system. So it should not change that data too much, right? So it is a kind of a mirror to the operational systems that we have. So these are like conflicting kind of requirements, but we'll be discussing this when we talk about the data quality subsystem. And security, so do not publish data widely to all decision makers. So it should be need based and not it should not be broadcast to everybody. And then there are data integration requirements, where we have master data management systems like MDM, and here we try to conform dimensions and facts that are there. So conforming dimensions basically mean that a particular dimension may be applicable or may apply to multiple facts, right, that are there, fact tables that are there. So without making multiple copies of the dimension tables, we need to be able to link them to different facts. And similarly, facts should also be conformed, that is, they should be present, they could be present in multiple fact tables, and things like drill across should be possible, right? Drill across is a kind of a query where you try to connect information that is there in more than 2 fact tables. Then there is a very important factor, and this has some bearing on real-time data warehousing as well. So data latency, and it basically, what is your latency requirement? Say if you are not, if you say that, okay, every month if my data warehouse is refreshed, so my latency, this latency requirement is not going to put any kind of pressure on the ETL system. But if you say that I want my data every hour, right, I want my data to be refreshed every hour, so then it can become a problem, like it happens in the case of real-time data warehousing. So that is also scheduled later in the course. I think it is module number 9 or 10. One of those modules is on real-time data warehousing. I think module number 10. So use data. So for this, we need to use efficient data processing algorithms. We must use parallelization wherever possible, and very powerful hardware to speed up batch-oriented data flows. And if the requirement is for real time, so this is what I was trying to, then architecture must make a switch from batch to micro batch or stream oriented. So stream oriented, in a stream batch oriented means you may want to stage the data and then process it and then put it in the data warehouse. In stream oriented, you don't stage the area, you just process it as it comes and then puts it directly into the data warehouse. But stream oriented is typically done when you have a serious concern about the latency. And then we have archiving and lineage. So must for compliance and security reasons. So you must archive all the data that is there, so no data is ever expunged. Maybe it is even if it is no longer part of the data warehouse, so you should always archive all the data that is there. And lineage means you try to see where from, what is the origin of the data, what kind of transformations it has gone through, and in what form it is finally there in the data warehouse. So this is also called as, loosely speaking, this is also referred to as data provenance problem. So where we try to track the origin and the transformations of data. And after every major activity of ETL pipeline, writing the data to disk, that is what we call a staging, is recommended, so that it is easy to see the different stages of the data. And all stage data should be archived. It should never be deleted from the system. So now let me, before I give you more details about ETL, I mean the 3 steps: extract, transformation, and load, let me do a kind of trade-off or kind of comparative analysis between tool-based ETL. Tool-based ETL means a tool that you buy off the shelf, right? And versus hand-coded ETL. So these are two kinds of options that you have when you start working on an ETL project. So tool-based ETL, so they are simple, they are simpler, cheaper, and faster development because you're just buying them. So deploying them is easy, and you can start using it very, very quickly. People with business skills and not much technical skills can use it because it is already most of these tools come with a nice interface, and that is a graphical interface. And the other good thing about these tools is that they automatically generate the metadata that is required, and also automatically generate the data lineage and data dependency analysis. So most of the requirements of the ETL are fulfilled by these by these tools that are available, and offers inline encryption and compression capabilities, and this is also very, very important. So encryption is basically required for security reasons, especially when you are trying to use a public network for transferring data from the source systems to the data warehouse. And compression is basically required so that large volumes of data can be compressed and sent over the channel. And the last point in this is that manage complex load balancing across servers. So you may deploy multiple servers. So ETL tools come with a kind of a load balancing feature, which can distribute your work among different servers that you are using. Then comes the hand-coded ETL. So here, so quality of tool is very good because you have done exhaustive unit testing on this, and it requires it can generate better metadata, and require maybe just file-based processes, not database stored procedures. So most of the time, as you will see in the coming slides, that most of the processing for ETL happens in flat files, right, and not necessarily in databases. And there are other kinds of platforms on which you do the ETL. And use of existing legacy routines. So whatever legacy routines you had earlier, you can use them. And whatever programs you have developed in-house, those can also be used. And it offers you unlimited flexibility. Unlimited flexibility in the sense that if you are not satisfied with any particular aspect of this ETL tool, you can go and change it, right? And this may or may not be possible with the tool-based ETL. And since you are developing it in-house, it is much cheaper to develop this hand-coded ETL. And then we have what are called as middleware and connectivity tools. So these are basically for connecting to heterogeneous computing environments on which the source systems are running. So provide transparent access to source systems in heterogeneous computing environments. This includes both the software and the hardware. And expensive but often prove invaluable because they provide transparent access to databases of different types residing on different platforms. So these tools are expensive, but they are worth it because they kind of provide a very seamless kind of interface with different types of databases. And you have examples like Data Joiner from IBM, Transparent Gateway from Oracle, and SAS has something called as SAS Connect, and Sybase has something called as Enterprise Connect. So now, after talking about the requirements and the discussion about whether we should hard code the ETL or we should just buy an off-the-shelf tool, we now come to the extract phase, right? And this extract phase is very important because it decides, through this you decide what data gets into the data warehouse. So let me come to this, So it is all about what data you want in the data warehouse. And remember that right at the beginning of the course I mentioned that not all data that is generated by operational systems is required in the data warehouse. So for example, credit card number is mandatory in operational systems. Say if you are trying to do an online purchase and you want to use your credit card, you cannot do it without the credit card number. But once this transaction goes into the data warehouse, I may say that I don't need the credit card number, because there is no analysis which I can do on a particular credit card number. So what I need, what is important for me is that how I have completed the transaction, how I have made the payment. That is more important than the credit card number in a data warehouse. So not all information that is generated in the operational or production systems is required in the data warehouse, and typically implemented as a GUI. So this GUI, I'll just try to give you some idea about how it looks. So it'll give you a list of tables. So suppose this is my interface, so and I'm just drawing them like this. These are list of tables, right? And suppose I select this one, so this one comes here, and then all the columns are marked, like what all the entire schema is kind of displayed, and then you can select which attributes you want, which attributes you want to combine, which attributes you want to split. So all those things you can carry out in this extract phase. So it is typically a GUI, a very nice GUI. And table names and the schema is displayed for extraction. This is what I was telling you just now. And tables are selected, and then their attributes are selected. So it may be, say that I don't need this table, I need this table, I need this table, I just need this table. Now from this table I may say that I need only 2 attributes. So if I'm doing it column wise, so I can say that I need this and I need this. Rest of the attributes I don't need. So that way you can specify, and at the same time you can also specify transformations. Then we have what are called as extraction tools, so there are lots of extraction tools available in the market, and so much so that the selection becomes tedious. Like a decade back, or maybe 15 years back, if you went out to buy a car, you had only 2 options, right? A Maruti or an Ambassador, right? Or possibly Fiat, right? So only 3 models are available, so you can very quickly, it is easier for you to make a choice. But now if you go to the market to buy a car, there are hundreds and hundreds of models to choose from. So tool selection is tedious that way, alright. So because ETL tools, they come in different shapes and sizes, so tool selection becomes really very tedious. And but there are some guidelines, or there are some aspects of every ETL tool that you must, some features that you must always look into before investing in an ETL tool. So what is the source system, platform and database that you have? Built-in extraction or duplication functionality. So you need to have extraction functionality as well as duplication functionality, because you want to take the same thing to the data warehouse. And batch windows of operational system. So like, what is the window size? That how much time do you have for the operational systems? Because as I told you, every period of time you need to refresh your data warehouse, right? So what is that batch window of the operational systems? How much time I have to do that? And then there are extraction methods. There are 2 types of methods. One is called bulk extractions. So entire data warehouse is refreshed periodically, but it heavily taxes the network connection between the source and target databases. And if you're doing it over the internet, then it becomes even more tricky. But it is easier to set up and maintain. So you have to just set it up and schedule it properly. So these bulk extractions are much simpler that way. Change-based extractions, only data that have been newly inserted or updated in the source systems are extracted and loaded into the data warehouse. And so here what I do is, if I did my refresh today and say, okay, I'm here, sorry, say I'm here. So these are different days in which I'm refreshing. So what happened in the conventional systems, this entire data that is generated between 2 refresh cycles has to be uploaded here. Now what I'm saying is, in the data warehouse, now can I just see what changes have happened and propagate only the changes to the data warehouse? So definitely the second approach is much more effective or efficient, but it is difficult to implement because as a member of the data warehouse team, or even if you are the lead of the data warehousing project, you may not have any kind of control over the legacy systems and the other kinds of systems, or the operational systems or the ERP, so that you can dictate that they should mark all the changes in the database. So that is not possible. So this is change-based extractions are more tedious. And transformation tools. So here I'm now trying to give you some idea about the kind of transformations that we need to carry out on the data, and there are lots of tools that do that, and most of them are different from each other in terms of what features they provide, but they have a commonality in terms of a lot of features that should be there as part of any transformation tool. So transform extracted data into the appropriate format, which in our case is the dimensional model, data structures and values that are required by the data warehouse, right? And features provided are split, field splitting and consolidation. So sometimes I may want to split a field into a couple of fields, like for example address. So I would want to split it into atomic data so that I know what city you come from. In the absence of something like this, you need to basically look at the entire address string and then try to figure out where is the city, right, or which part of the string represents city. So those kind of things are required in this. So field splitting and consolidation is there. So address, I may want to split it into multiple fields. Consolidation, sometimes I may want to combine two fields into one, right? So that is also possible. I'm not able to think of an example straight away, but I think in the next slide I have one such example. And then we talk about standardization. So here we take care of abbreviations, date formats, data types. Say then we have character formats or character strings, time zones, currencies, metric systems. Say in one operational system it is the FPS system, and in the other one it is the MI system. Product keys. Say the same product is being represented by different keys in different systems, so you need to come at a common product code or product keys. Then coding. Say in many applications I've seen that male is represented by 1 and female represented by 0. But there may be another system where this is just the other way around. Females are 1 and males are 0. So if you just bring in this data like this, then you would lose all information on the gender, right? And similarly, there are these currencies. There are different kinds of currencies that are there. So whether you want the currency of the host country of the organization or where it originally comes from. So all these are issues that you need to address. Then we have what is called as deduplication. Now deduplication as such, it appears very innocuous, right? Because we know that we can write a deduplication program, but it is actually a very tedious task. Say if I give you 100 million customers, right, for a company, okay, so and I ask you, maybe 100 million is a bit too large a number, so let me say 1 million customers, okay. So if I give you 1 million customers, and I now say that there may be some customers which are duplicate in this, right? So now your job is to figure out which all customers are there appearing twice, two times or more in my database, right? So this is a major non-trivial task. Excuse me. So now I'm going to give you some idea about the field splitting and also field consolidation. I was not able to recall this. And some other kinds of transformations. So let me clear this. Okay. So if you look at the first column, first column and the second column and the third column. So first column represents that or tells us that how the data looks like in the source system. The second is what kind of transformation I'm going to carry out, and finally how the data would look like in the data warehouse. So if you look at this, so this is the address field. Okay, so what we have done is we have split this into 1, 2, 3, 4 values. So first is the street, so I'm saying the street is ABC, city is the XYZ, country is Republic of MN, and fourth is the postal code. So somehow I'm able to extract this information from this information. Right, so think about having many different ways of writing or writing address, right, and then a kind of code running on top of this address to give you these 4 different fields. Now look at the second example, which is called as field consolidation. So system A, the title is, the customer title is president. In system B, it is, the title is CEO. And if I say that I want to use field consolidation, so that means the customer title should be president and CEO. And then dates are always very typical to handle because of the different date formats that we have. We follow a different date format than the US. So it is always good to specify the month name, right? So order date is 5th August and order date is 8 August 98. This is another record. So you can say that this this record is coming from source system 1 and this record is coming from source system 2. Okay, so suppose this is for a particular product. So if I look at these 2 dates, I may say that they sold on different dates. But if you now look at the standardization aspect of transformation, so you can see that the order date for the first one is 5th August as it is, and the second one we are saying that the order date is 8th August 1998. So this is what is standardization. Sorry. And then finally we have, say, duplicate customer records or product records or anything. Anything can appear more than once in a database. Unplanned way, in an unplanned way. You have not planned it that way. So if you see this, system A says that customer name is John W. Smith and system B is John William Smith, right? So it appears that they are the same, these 2 customers are the same. But before you take a call, you need to look at the other attributes that they have, and if the other attributes match, then only you say that these 2 are the same person, and you end up putting the customer name as John William Smith. You could have also written John W. Smith, but it is always good to expand all the initials so that later when you are looking for this person, there is no confusion. And mission. So let me now come to the mission of the ETL team. So to build the backroom of the data warehouse and deliver data most effectively to end user tools and add value to the data in the form of cleaning and conforming and protect and document the lineage of data. So we also call it the data provenance. And must support these 4 steps: extracting data, quality assuring and cleaning, conforming labels and measures, right, and delivering the data in physical format that can be used by query tools and report writers. And here, as I said, we are referring to dimensional modeling. Then we have what are called as data structures. Oh, sorry. We have these. Sorry, I think I missed one slide. Sorry, just wait a minute. Something went wrong. Yeah. So data structures. So here, what we do is so the data flow. If you look at the data flow part of in ETL, you will notice a couple of things here. So you extract, clean, conform, and deliver. So clean and conform, this together is actually called as transform, right? And so the back room of a data warehouse is often called as the data staging area. Staging means writing to disk, as I explained to you earlier. And this data staging area, as I said, this term is not is no longer used these days. So better term is backroom for a data warehouse. And ETL team needs a number of different data structures for all kinds of staging needs. So depending upon the kind of processing you want to do, so you would want to choose a suitable data structure for doing this. To stage or not to stage, so this basically is about whether you should use batch mode of processing, and you try to save your data onto disk. So decision to store data in physical staging area versus processing it in memory is ultimately the choice of the ETL architect. So it all depends on your requirements. Because staging, if you do staging, then you are getting involved in I/O. And to stage or not to stage, a conflict between getting the data from the operational systems as fast as possible and having the ability to start without repeating the process from the beginning, right? So if you are not staging, then you'll have to start from the scratch, right? And reasons for staging in favor of staging are recoverability, okay, backup, and auditing. So these are some situations or some reasons for you to stage. Again, but if your requirement is more time critical in the sense that you want to do some real-time data warehousing, then staging may not be a good option. And if you look at the back room, so I'm now trying to give you some details of what happens in the back room. So it is owned by the ETL team, and there are no indexes, no aggregations, no presentation access, that means no user can access it, no querying, and no service level agreements at this SLAs at this level. And users are not allowed, and it's a kind of a construction site, and it is, as you know, it is not safe to be at a construction site. And reports cannot access data in the back room, so that also I have told you. So we continue with that. So only ETL process can read write in the back room. And ETL developers must capture table names, update strategies, and load frequency, ETL jobs, expected growth of the table, and other details about the staging area. And this backroom is not necessarily relational. It may have lots of data in form of flat files. So this flat file processing is also very critical for ETL. And as I said, data structures, again, some more details about that. You have flat files, which are fast to write, append to, filter, applying some kind of filter or grep, but they are slow to update, access, or join. So if you have data in two files, and if you want to combine information that is there in these two files, then it would require you to write a very involved piece of code. But if you have your data in relational tables, then the join operation is very well defined and supported. And then XML data sets used as a medium of data transfer between incompatible data sources. So XML has its own role in ETL because of it tries to act. It acts basically acts as a bridge between different between incompatible data sources. And then finally we have what are called as relational tables. So I have not put any details because all of you are familiar with what kind of capabilities we have when our data is there in relational databases. And after this, I'll be talking about 34 subsystems of ETL. So these subsystems define each and every aspect of an ETL tool, right? So the next lecture will be on these subsystems, 34 subsystems, and I think it will be good if I can split this into 2 sessions. Okay, so so there are basically 4 major tasks, and these 34 subsystems are divided among those 4 major tasks. So I'll try to cover 2 tasks in the next lecture. Till then, you need to look at the detailed descriptions that are given in the book for ETL. So that would help you understand these subsystems better. So with that, I end this recorded lecture. Thank you.